All right, number 15 says, an airplane is preparing to land on a runway of a local airport. The graph at the right outlines the projected path. It asks you different questions. It says, what is the rate of descent? What does the slope represent in this situation? And what does the point 30 and 750 represent? Okay, first off, rate of descent. Rate of descent, it's asking us for the rate of change. It's asking us for the slope. They want to know what the slope of this line is. So what you have to do is you have to find good points that work in order to find your delta y over delta x, your change in y over your change in x. Remember that your slope is rise over run, delta y over delta x. It's telling you how many you go up or down over how many you go across. Now in this situation, this line, are we increasing or decreasing? We are decreasing. We are going down. So that means my slope is going to be negative. Okay, so we're going to have to figure out how many down and to the right we're going to go. One way we've talked about doing this already is finding the x and the y-intercept. The x-intercept, kind of, this graph is all smushed together, but the x-intercept is up here at 0 and 1500. Now I like to go and find my x-intercept. It tends to be the easiest. And I'm going to put a dot down here on my x-intercept. That's where it crosses the x-axis. That is 60 and 0. Now, to find your rate of change, I'm going to find out how many I go down and how many I go over. So I'm going to go down 1500. That's negative 1500 over, and then I go to the right 60. Now, if you will just take this, we can reduce it and find out what our rate of change is. Let me remind you in the calculator. I pull that up. So if we go in there and we put negative 1500 divided by 60 and press enter, it'll give us a negative 25. So that says, let me move over here, equals negative 25. That's my slope. That's my rate of descent. But what does that mean? When it's asking you what the slope represents, you have to look at what is on your graph. If you will do it this way every time, you will get it right. It is, if you think of it as y per x. Now, y per x is not the answer, but I know my x and my y on the graph. So what I can look at, y is the distance in feet. So it will be feet per, and on the x-axis, it's the time in seconds. So it's feet per second. See, that's how fast that plane is going down, feet per second. But if you think of it as, when they ask you what does the slope represent, y per x, and look on your graph, whatever the y is, per whatever the x is, that'll help give you your answer. Now, the next thing says, what does the point 30 and 750 represent? Well, 30 is the x, 750 is the y. Well, the x is the number of seconds, so it means that at 30 seconds, the plane is 750 is at 750 feet. Because the y is the feet. So when they give you an ordered pair, you just look at what the x number is and then what the label is on the x-axis to tell you what it is. Now, if I want to continue from this problem, I could also ask you, what is the y-intercept? We went up here and we found my y-intercept right here. That was 0 and 1500. Another question you will be asked on your test is, what does that represent? What does that mean in this problem? Well, 0 and 1500, whenever you have the y-intercept, it's going to be some kind of initial charge, starting point, deposit, something that you pay for one time or that you start at. In this case, this is the height. This is the height at the beginning of the plane's descent. The height, I would have this down for our notes. The height of the beginning of the plane's descent. Now, if it asked us for an equation, okay? An equation in slope-intercept form is y equals mx plus b. Remember, m is the slope. B is the y-intercept. Well, so I have y equals, we found the slope to be negative 25. And then you put the x, and the y-intercept is a positive 1500. You can write it that way, or you can write y equals 1500 minus 25x. That means the same thing. Okay, now, I want to talk about a few things before we go back, because we're going backwards and we're going to go to these point problems right here, 13 and 14, where it's asking you to find the slope. Let's talk about slope for a second. And this is on your separate sheet of paper that I want you to have this written down. When we've done slope, okay, if I've given you 2 points in the past, how have we talked about finding the rate of change here? Doing what? What would we put the points in? What? A table. So if I go to put the points in a table, I would have gone, I've got x and y, and I would have put in there 2, 6, and 3, 10. Now to find the slope, which is the same as finding a coefficient, we did it when we were trying to find if things were linear, was we would go and do delta y over delta x. Delta y right here is plus 4. Delta x is 1. So I would have done delta y over delta x, and that would have been 4 divided by 1, which is 4. 4 would be my slope. That's what we've done before. We've also talked about graphing. I didn't make very nice points here. Let's see. 1, 2, for my graph, I mean 3, 4, 5, 6, 7, 8, 9, 10. Kind of crooked, whatever. 1, 2, 3, 4, 5. Okay. So we've talked about when we have points on a graph. 2, 6, going over to 2 and up to 6. 1, 2, 3, 4, 5, 6. And 3, 10. Let's see. Then we have our line. What we've talked about before on finding your slope is counting how many up and how many over. I'm going up 1, 2, 3, 4. Because how many you go up and down, the rise and the run, that's delta y. And then over, we went 1, and that's delta x. Again, the change in y over the change in x, 4 over 1. Where we can find it in a table, or we can find it on a graph. Now we have another way that we can find the slope. So let me make sure I have the same points. Let's see, I have 2, 6, 2, 6, and 3, 10. It is the slope formula. Okay, so make sure you have this down. Slope formula. The formula for the slope is y2 minus y1 over x2 minus x1. That's going to give you m, which is the slope. Honestly, this is the same thing you do in a table. You just don't have to build the table if you don't want to. So what I'm going to do is identify. I have x1, y1, x2, y2. Now, you're going to do y2 minus y1. Well, y2 is 10, so I'm going to do 10 minus. y1 is 6 over x2 is 3 minus x1, which is 2. So now when you do that, 10 minus 6 is 4. 3 minus 2 is 1. 4 divided by 1 is 4. It's just another way, but the reason why they want us to show you is because on your formula chart for your EOCs, they are going to give you this slope formula. So maybe you don't remember how to table builder, which I hope that's not the case, but you can always use that formula. So let's look at problem number 14. Or I lied, we'll do the odd ones. Let's do number 13 because we did 15. All right, so number 13. Number 13, if we look at this, I'm going to label mine x1, y1, x2, y2 above your points. Please do that on yours. The formula, y2 minus y1, so let's see, y2 minus y1 over x2 minus x1. Okay, y2, 9 minus, now look, that's a -2, so you have to be careful. You have to put -2. Look what I did. That minus always stays there, and then a -2. Over x2, which is 4, minus x1, which is 4. Now, remember when you guys were doing integers last year? When you add two negatives, what did it make it become? A positive. So a negative times a negative is a positive. So this becomes plus, and now I get 9 plus 2, which is 7, over 4 minus 4, which is what? 0. Uh-oh. Right now, put in your calculators 7 minus 0. Go and do that now. We'll go in here and we're going to put 7. It's not 7. 7. Oh, good gravy. Here we go. 7 divided by, oh, I did say minus. I apologize. I meant divide. 7 divided by 0. My bad. It does. It says, actually it says right? Divide by 0. That's because you can't divide by 0. Okay? You can't divide by 0, so there's not a number that is the slope. When this happens, your slope is undefined. And you write undefined when they ask you what is your slope. Now, if I went to graph this, if I went to graph these 2 points, I have 4, -2. 1, 2, 3, 4, -2. I put a point there. And I have 4, 9. So I would go up here to 9, over 4 and up 9. When I go to draw this line, what type of line is this? This is a vertical line. Vertical lines have an undefined slope. You have to know that. Now, one way you can look at this is seeing, okay, well, if I see this line and I know it's vertical, the U is kind of like the V, so vertical would be an undefined slope. When you look at the ordered pairs up here, what do you notice about which letters are the same? The X's are the same. The X's are both 4. Everywhere on this line, the X numbers are 4. The equation for a vertical line is X equals, and then whatever the X number is. So it's X equals 4. All right, let's go back and let's look at number 11. Okay, looking at number 11, I have x1, y1, x2, y2. We're going to use the slope formula, which is y2 minus y1 over x2 minus x1. All right, so now let's look. Y2 is -4, so you should have written down -4 minus y1 is 2 over x2 is 8 minus x1 is 5. -4 minus 2 is -6. 8 minus 5 is 3. What's -6 divided by 3? -2. My slope is -2. Okay, so all you're doing is plugging it into the formula. You put the answer right here, like I did right there, yes. Okay, let's look at number 9. Number 9, we have a graph. What type of line is this line? It is a vertical line. On your paper, I want you to write vertical. Verticals? Nice. All right, vertical. What did we say the slope of a vertical line always is? Undefined. So right here on the slope, you're going to write undefined. Now it wants us, I guess I need to circle vertical down here. It wants us to state what is the y-intercept. Does it cross the y-axis right here? No, it doesn't touch it. So you just write none. Now the x-intercept going across right here on the x-axis, it does cross at what point? It crosses, that point right there is at 6, 0. That's my x-intercept. 6, 0. Now, the equation of a vertical line is going to be x equals whatever the x number is of my x-intercept. It's x equals 6. Now, number 7, what type of line is number 7? 7 is right here, goes across. That is a horizontal line. Okay, horizontal lines have a slope of 0 because you go up nothing, up 0, and to the right as many numbers as you need. 0 divided by any number is 0. Now, the y-intercept. Where does this line cross the y-axis? at 0, -4. Yeah, -4 because it's down below. I'll try and write that better here. 0 and 0, -4. Now my x-intercepts, where does this cross the x-axis right here? No, it does not touch it, so we just write none. Now for your equation, everywhere on this line, all the y numbers are always -4. So my equation is y equals -4. Vertical and horizontal lines have special properties. Now, there's lots of ways that I talk about trying to remember which one is undefined and which one is 0. One of the ways in that note page I want you to have, we call it Hoy Vux. I know, Hoy Vux. H-O-Y. I know, it sounds like I'm cursing or something. Vux is V-U-X. Now, Hoy, what does Hoy stand for? H is horizontal, 0 slope. Y equals is the equation. Another way I talk about remembering, see if I can get my highlighter here. Another way I try and remember this is because horizontal has a Z in it, 0 has a Z in it. So I try and remind myself that a horizontal line has a 0 slope from just that. Now the Vux, this is a vertical line. Vertical lines have an undefined slope. And the equation is x equals some number. Okay? So, for example, I just, the horizontals would be like y equals 7, y equals -2. My vertical lines would be x equals 4, x equals -3. But those are what those are for on your vertical and horizontal lines. Let's look at number 5. On number 5, the first thing we need to look at is it asks us, is this line increasing or decreasing? And remember, you have to look from left to right. The line is going up. From left to right, it's going up on number 5. That means it's increasing. I'm number 5. I'm doing the odds. Okay? Now, it wants the slope and the x and the y-intercept. Honestly, I go to the x and y-intercepts first. The y-intercept, go on your paper right now, and I want you to put a dot on your y-intercept. That point is 0, 3. Your x-intercept, you're looking on your x-axis. Hopefully it crosses in a nice place. It doesn't always. In this case, it does. It's -6, 0. Now, we need to find the slope. Okay? Some of y'all need to focus with me. We need to find the slope. You can do it one of 2 ways, and I'm going to do, well, one of 3 ways. There's a bunch of different ways. I'm going to do it a couple ways. One way to do the slope is to figure out your rise over run. Since it's positive, I'm going up and then to the right. So I'm going to start at my x-intercept, and I'm going to go up 3 and to the right 6. 3 over 6 reduces to 1/2. One of the mistakes will be people will say 2 because they're going to take the bottom divided by the top. No, no, no. Take the top number divided by the bottom. And really, if you'll just go in the calculator and put in there, oh, gee, here we go again. I have to do a certain thing. All right. Oh my goodness, here we go. Come on. All right. If you'll go in there and put 3, divide 6, press math, enter, enter, it will reduce your fraction for you. Now, my slope now is 1/2. But I also want to show you that I can do the slope formula as well. I can use my x and y intercepts as y1 and y2. See, I have 0, 3, and 6, 0. I can use these as x1, y1, x2, y2 if you can't read your graphs. So I can go and do y2, which is 0, minus y1, which is 3, over x2, which is negative 6, minus 0. And now, 0 minus 3 is negative 3. Negative 6 minus 0 is negative 6. Again, when you go to reduce that in your calculator, when you have negative 3 divided by negative 6, math, enter, enter, that's giving you 1/2. So these are two different ways to find your slope. Now, what two pieces of information do I need to write my equation? I need my slope and my y-intercept. So I have y equals, then I put my slope, which is 1/2 x, and my y-intercept, which is plus 3. There's my equation. To make sure that you did it right, go to the calculator, go to y equals, and put in there 1/2 x plus 3 and press graph. Your line should match that. That's one of the biggest reasons you do that, is so that you make sure your slopes are positive and negative and you're doing them in the right direction. Take a minute and do number 3 and number 1. Do number 3 and number 1. All right, on number 3, let me put a shade up here to kind of cover things up. All right, on number 3, I'm looking at my line, and I'm looking from left to right. What is happening to my line? Is my line going up or going down? It's going up, so that means it's increasing. So now I'm going to go and try and find my x and my y-intercepts. My y-intercept up here is 0, 7. So I'm going to go on my table and put in there 0, 7, or on the blank. The x-intercept, where it crosses the x-axis, sometimes you guys need to label x and y. This one is at negative 7, but look, negative 7, 0. I really need you to pay attention to the way that they are written. A y-intercept has the number in the y spot. An x-intercept has the number written in the x spot. Please understand they will try and trick you on the test by switching the numbers and the zeros. Now, to find the slope, you can do the slope formula. If, let's see, if I did 0, 7 and negative 7, 0, if I did that, oh golly gee, I need some more room here. I would take, remember I've got x1, y1, x2, y2. y2 minus y1. 0 minus 7. Over x2 minus x1. Negative 7 minus 0. That gives me negative 7 over negative 7. Negative 7 divided by negative 7 is positive 1. My slope should be a 1. This change, if I looked at it in the table, I would be going up 7 and to the right 7, where I have 7 divided by 7 which is 1. Now you can write the equation. Y equals 1x. Now, which one do I use? We should use the plus 7. Now, another way that you might see this written is just y equals x plus 7. Okay? They won't show the 1 on there. All right, so let's look at number 1. Okay, looking at number 1. All right, on number 1, looking again from left to right, is the line going up or going down? It is going up, so it is increasing. So now I need to find, I'm going to find my x and my y-intercepts. Some of you need to label x and y. I'm going to go on the y-axis and put a dot. That is 0, 2. Y-intercept has a number in the y spot. The x-intercept is right here. That is actually -2, 0. And no, they are not always opposites like this. It just ends up being a coincidence on the ones I've chosen. Now the slope, I'm going to choose to do the graph because I found nice points. I'm going to go up 2 and to the right 2. 2 divided by 2 is 1. Again, you can still do y2 minus y1 and x2 minus x1. My equation becomes y equals 1x. And make sure to use your y-intercept, so it should be plus 2 is what you should have gotten. Y equals x plus 2 is a better way of writing it.